Hey, Alex Williams here, and this lesson is going to be on Tic-Tac-Toe. This is going to be the entire project from start to finish. I could do separate videos for each different part, but I'm just going to do the entire thing, and I'll timestamp in the comments below where the different sections are. So I'm going to do the framework with the constructor and the display maze method, the taking turns, and then finally checking the win. But I will timestamp it so that if you just want to look at the CheckWin, just look at the timestamp, click on that, you'll go straight to that section. And I won't mix it up. I'll do the entire bit of each one in each section. All right, and with that, let's take a look at this project here. I created this earlier this semester. Just noughts and crosses. You're just taking turns. Player X, if I type the 1, it'll put it there. If I type 1 again for player O, it should not do it. It does not. So it has to be a valid move. So we can keep going. And if I do 9, it should check for a win. This version doesn't. And it should also, the other thing it should do is if I type something that's not a valid move, it should not crash. This one does. But with that, let's get started. We're going to do something slightly different. And there we go. So, all right, so we could jump into Visual Studio, obviously create a project called TicTacToe. I think this semester it's project 2, maybe, if you're still working on it this semester, 20 SP day. If not, it could be a different project number. So we're starting off in main, and normally I would do this. I would just type board. I would type out the line as I expect to see it, and then ask Visual Studio to fix it. But for this one, I'm going to actually do it the straightforward way and right click on my project, click add, and we're going to say class. So we're adding a class, and the class we're adding is going to be a board. We want to create a class that contains our board and the logic for working with that board. All right, so I have my board class. It's up here. I can click on program. This is my main program, and I'm going to create a new instance of the board. And I can call it board. I could call it lowercase board. I could call it whatever I want. I'm going to call this one game. I like to change that up just so people don't feel like there's a logical reason why you would have the same name there. There isn't. We just do this. By convention, sometimes you have it the same name. So I have my new instance of a board called game. And then this is the framework of the program. I want a game loop. So the first thing I'm going to do is I'm going to create a Boolean that says whether or not the game should keep running. And I'll say, I'm going to call this one exit game. I like to mix this up too, just to demonstrate that the logic that you build into it really doesn't matter exactly the construct of it, as long as it makes sense and you understand it. All right, so while not exit game. So we're going to say keep doing this loop while we're not exiting the game. And then what I'm going to want to do here is I'm going to want to display the board. I'm going to want to take a turn. And finally, we're going to want to check for a win. See if the turn that was taken has just created a win. Also in here, we're also going to want to see if they want to exit. I'm probably not going to implement like a quit to exit. I'm just going to check for a win, and if they win, display something and then exit. So that's this section here. So we have to put these, at least stub these out in our board class. So we're going to do a display board, take turn, and check for win. Again, you can do it this way, game.displayBoard. I could do that and just tell Visual Studio control dot to fix it. And it fixes it. F12, if I'm on it, will bring me right to that method. So it'll just jump me right from here to here. Or I could just go there directly. I get rid of that. And we also have, we could say internal void check win, we're going to need and we also need a take turn. So you can do it either way. You could just type it directly and then go back here and say game dot game dot take turn. You can see why I like to do it the reverse way because it's fewer steps. Game dot CheckWin. All right. And actually, I'm going to set this up later that this CheckWin returns a value, and then we can know who won, and then we can use that value to decide that we're going to quit or display a message. But for now, I'm just going to stub it out like this. And then the other thing in the board game there is we're going to need to do to actually have a constructor. But that's going to be the next section. So now we're going to start with the constructor. And I will timestamp it right here. So the constructor, as you know, is a CTOR. And this is the default constructor. This constructor is just empty. And this is actually, whether or not this exists or you see this, it actually exists in every class. Now we can change it and we'll have more than just a default constructor, but so we're just going to use this for now as a default constructor. And then we need a data structure to hold our board. And the data structure that we are going to use is char cells. And we can use a single dimensional array from 0 to 9 or 0 to 8, I should say. And we could figure out which ones they are. But it's easier, I think, to think of it in terms of a two-dimensional array where you have rows and columns. And we just do it like that. Oop, no, I did it backwards. All right, so there's our cells. And then in our board class here, we're going to initialize that. Cells equals new character, and of course it's 3 by 3. All right, and that's it. This will hold our characters. Right now it should be filled with just empty spaces. And that's really it for the constructor right now. We're going to need one more thing here. The way I'm going to implement this one is that you're going to have a board and it's going to have a currently selected cell. And in order to do that, I say int current row and int current column. Yeah, that should work. And then to start with, I'm just going to make current row and current column equal to 1. So that'll be actually the middle because it's a 0. These are 0 index, so it's 0, 1, 2. 1 is right in the middle of that. And then current row equals 1 as well. All right. So that's the construction of this right here. The next thing I'm going to do is going to be this display board. And yeah, I'm going to do that first, and then I'll put the player in a minute. All right, so the display board. All we need to do in the display board is to create a loop or a nested loop that iterates through each one of these cells and displays it to the screen. So obviously we're going to start with a for loop, and we could use X's and Y's, but of course our players are X's and O's, and that's going to get really confusing. So with this one, I like to use row and column for my nested loops. Column, there. And let me see if I get that right. So it's going to be, it's the reverse of this. So we're going to do row and column. So, and inside here, I am going to display my cell. And the cell is going to look like this. Console.write. Wow. Actually, I want to do write. And am I missing a using statement? I am. So I am missing a using. I'm missing using system. And write takes a variable, parameter. All right, so console.write. And inside here, I'm going to make it look like this. Right? And then in between here, in this space here, I'm going to put a character, which is going to be whatever is in that two-dimensional array. Cells, let's say column, row. There we go. All right, so we're going column, row. And right now, these should be spaces, so just blank spaces. And if I run this, actually, it's going to look terrible because I missed a couple of things. One thing I missed is I do want to do console.clear so that it stops. And then at the end of this first loop here, it's going to write it across. We want to write one line down, so we write on the next line. Sol.write line. So it's going to just drop a line. And then lastly, our game loop currently has it running through this and taking a turn. At a minimum, take turn should at least ask the player to press a button. Otherwise, it's going to just loop through this infinitely, and it's probably you're not going to really see much on the screen. So our take turn, I'm just going to put in here. And for taking turns, I want to get the key press, not just a character, but an actual like up arrow, down arrow. So for that, I need to say console key, we'll say input equals, and then we say console dot read key, which returns a console key info object, and a property of that is the key. Console key dot key. So we're going to read the console and get the key and put it in this input. And for now, we're not going to use this. We're just using that to stop the flow of the program so that we can see what's being displayed. So this is all we have right now is a grid. If I hit enter, whatever I hit, it's just going to take that input and then display it again. The only other thing I want to do is I want to display the currently selected row and column. So I want to make sure that somehow it indicates that the row and column that's currently selected looks different than the other ones. So the player knows this is the cell that I'm currently on. So I could do two things. I could either do an if statement and say if row equals current row and column equals current column. I could display something different and then display this when it isn't equal to that. But what I want to do is I'm just going to do this. This is a really nice, clean way of doing it. Console dot background. I can change the background color equal to console color dot blue. If we're currently on 1, 1 in this iteration, if row and column are equal to 1, 1, display this but make it blue. And then at the end, I do want to change it back to black so that everything after this goes back to its normal color. And what's going to happen here is that center cell that's selected is just going to be highlighted to just indicate that this is the currently selected cell. That's it. So that's our display method. Not much more to that. The other thing now, the next thing, is going to be taking a turn. And I will timestamp this part here we're going to start with taking a turn. So to take a turn, we're here, we've displayed the board, it goes to take a turn, F12 just brings us right back here. We have our input, and what we're going to want to do is we're going to want to make a decision based on the input that the player makes. So actually, the keyword I just used was player. We need a player. So let's see. First thing we need is character player. And I'll call it current player just to be consistent. Current player. All right. And then in our constructor, we need to tell it what that player is. Current player equals, I'll call it X right there. And we could put variables up here for player 1 and player 2 equals X and 0 and use those instead. And we probably should, but for the purposes of this demonstration, I'm just going to do it like that. And now the first thing we want to do is display the player has to take a turn. So we say console.write line, and it should print right underneath the board itself. I'll say player plus current player. I'll just say it's your turn. All right, so quick run. Just always nice to run things. Player X, it's your turn. That's all it does. Player X, it's your turn. All right, so now we're going to switch. We're going to use a switch statement. We could use if statements, but I'm going to switch on that input. And hit enter, and it builds out the whole thing. I don't need any of this. Well, I didn't really need to do that. I could have just typed it, but let's just do that. And the first thing I'm going to want to do is I'm going to want the player to have the option to hit the arrow keys to change the currently selected cell. And for that, I say console key dot up arrow. And all I need to do is say current row, current row minus minus. We're going backwards. 0 is at the top, 2 is at the bottom. That's all I would need to do. However, what happens is if it's on 0, it's going to go to -1. So what I want it to do is say console row equals or minus equals 1, or yeah, let's do it this way. Console current row equals current row -1. And by normal math standards, I could use a modulus here, 3, and that would loop around back to the top. However, with C#, there's some issues. Not sure if it's this version or every version, but modulus doesn't work well with negative numbers. So we have to actually do the opposite and add 2. So we go up. So if it was 0, it should be 2 and then modulus 3. And if it's 2, it becomes 4. Modulus 3 goes down to 1. You're doing the same thing, you're just looping around in the other direction is all. It's like adding 11 hours instead of subtracting 1 to a clock. You could do that math in your head and work that out. So I'm going to do that. I'm going to do what happens if we hit the down arrow. And we're actually just going to +1. It looks weird, but that actually works. Just going to do a quick test just to make sure that my logic is right and it works. Up arrow and down arrow, and I got them backwards. But I have the right idea. So we want to do current column. And it's possible I have these backwards. But that's okay. We're going to stick with that for now. A little bit of dyslexia going on, but don't worry. The logic is still the same. Okay. So we have those two. I'm going to do the same thing, only now with the left and right. And this is going to be current row, current row, current row, and current row again. All right. And it should be the same. So left arrow is going left, which is 2 to the right and back. Okay. But we'll just quickly test that just to make sure, because you don't want to go any further until you're sure that this is working. My right arrow, up arrow. Yeah, it's cool. All right. So now that I have that currently selected cell, all I have to do is add one more thing that says if the player hits the enter key, then we say the cells current column, comma, current row equals current player. All right. This is the basic way of just dropping that current player character into your array. So let's just double check that, make sure it works. Obviously the logic needs to be changed. I still move. I can hit X. And while we're not changing player, we can at least fill this up with things. The other thing we're not doing is we're not checking to see if it's a valid move. So it's probably just dropping, yeah, it's just dropping X's, even if there's already an X there, which we shouldn't allow. So there's 2 things we have to do. We have to check to see if it's already a current, if it's an available cell. So we say if this current column, current row equals that, then we do that. And then we switch the player. If current player equals X, current player equals O, and this is a terrible way to do this. We should have functions or methods to do this. No, it doesn't. Boolean it. Assignment. Okay. So we have that. Else, it's going to be, there's only 2 choices, so we're just going to set that to X. And that's it. I actually prefer the implementation of this where a current player is actually a number and it's 1 and -1, and you just say current player times equals -1. But this is much easier to understand. All right, so I'm going to run that just to make sure that this is actually working. If I hit enter, I'm not getting anything. Oh, you know why? Because the default here is not blank. This is not being filled with blanks, or it's not equal to that character. It's equal to some other default. So in order to do this, I'm going to do this. I'm going to say character blank equals this, and then I'm going to fill this up with that. I'll say fill cells. I'm going to create this method, and I'm going to actually iterate through the whole thing. This is a terrible way to do it. You know what? Let's do this in reverse. All right, ignore that. I'm going to just define this. I'm going to create that. And I'm just going to say blank equals whatever the default for a character is. So whatever gets put into this here, when I create a new instance of this, something is in here. I'm just going to capture that into this. And then down here, I can just compare to say if this is equal to whatever it was when you instantiated that array, we're done. I hope that makes sense. The other implementation was going to take a little while and be very clumsy and cumbersome. All right. So, and as you can see, I always do this differently every time. I'm not kidding on that. So let's just run that, see what happens. Yep, it recognizes that as a blank cell, and I can do that. I cannot put it in there if it exists, and I can keep going. And that's it for taking turns. The only other thing now, and I will timestamp this one, is to do the CheckWin. All right. So if you're just tuning in to this section, this is the CheckWin section. So we've filled up our array with X's and O's, and now we just have to do a CheckWin. And the way I'm going to do this is I'm going to return a character. And of course it's broken because there's nothing being returned right now. And I'm going to return the blank character that I just created in the previous section. There's a new construct I just decided on a minute ago. All right. So here we have to test. We have to say what defines a win in a tic-tac-toe board. And there's 8 different combinations. There's across, there's 3 down, then there's the 2 diagonals. There are a lot of different ways to do this. The easiest way to demo on this one is to just say if I could say cells, let's say 0, 0, equals, and I'm just going to do this. So I can say if cells 0, 0 equals cells 0, 1, and cells 0, 1 is equal to cells 0, 2, that is a win. If this is an O and this is an O and this is and obviously these are the same, so they're the same. And if that equals that, and that means that O has won. In that case, I can literally just return whatever is in cells 0, 0, because clearly he is the winner. Now technically, I only have to test for one of the players each turn. I only have to check for I could say if this equals the current player and this equals the current player, return current player, because depending on how you implemented it, that should work. But then you change your logic slightly so that the current player gets switched. And even in this case, yeah, I've switched the current player here. So I'd actually have to check the other player and see if they just won. Much easier just to test for a win every time with the same logic. So this would tell me if 0, 0, I think it's the top row, it could be the side row if I got my logic backwards. And it would tell me if they won. And then back here, I just have to say, let's say character win equals. So now this character is going to be either blank if nobody won, it's going to be an X if X won, and an O if O won. So I can say if win, and here's where it gets a little tricky because I have to say win equals that blank character that I just created. And the only way I can get access to that is to make this public. A little bit messy, but we're going to do that. So I can say with board win equals game dot blank. I have a win. I don't have a win. If it doesn't equal game dot blank, then we have a win. And I could say player console.writeLine player, and we say win. That's the character for the player. Wins. Yay. And then, of course, we want to do like a console.readLine, just so we give the player a minute to enjoy their win. Or read, doesn't really matter. And then we just say exit game equals true. And I do that again. Do that all the time. I have a lot of students who make that mistake and they feel bad. And I'm like, no, seriously, I do this all the time. Okay, so that should be it. We're just going to quickly run and test this. Again, I don't know, because I get things backwards all the time, whether it's the top row that's going to win or the bottom row. So I'm going to try both. There's my X. throw away an O there, X, throw away an O, X. Okay, so it is the top row. So it says player X wins. A little glitch here. I did not fill that in before I said the player wins. So I should probably display the board again right before I do that. And I should get rid of this player exits your turn. So let's do that quickly. All I have to do is just right here say game.DisplayBoard. And that'll display the board, display this, blah, blah, blah. And that's it. So for the rest of the win conditions, player X wins, enter, done. I would just go in here into my win conditions, and through the magic of television, I'm just going to pause this. Okay. So poof, it's done. I didn't want to make you watch me do the painful drawing this out. Essentially, you're just doing all 3 rows and then all 3 columns, and then you're doing 0 to 1 1 to 1 1, and then 2 2, and then 2 0 to 1 1 to 0 2. It's important to note in this implementation, you always want to return whatever one of these was. When I copied and pasted it, of course, the first thing that came up was this, and I want to change this to whatever's in that first cell so that you're returning a winner. And now if I run this, let's see. You can win in any direction. Of course, I don't know how to play my own game. There, player X wins, hit enter, and it exits. That's it. I will post this video, and the corresponding code I'll actually put up in my repository if you want to see it. And you're all set. All right. Thanks for watching.